The question is, what does the limit when the x approaches the 1 of x squared minus 1 over x plus 1 equal to? And as we can see from the values of our x, this question is basically about the function problems. And the reason why we could see that this is a function problem is because we know that the function, which we usually notate as our f of x, is a stuff that requires a specific input values. The function is a thing that requires a specific input values, which we'll notate as our x value, and the output values, which we're gonna notate as the y values. And input and the output values are the things that generates our function, because we know that we write our function or notate it as the f of x. So we notate our function as the f of x. And the reason why is because x value is our input and the f value is our y value, which will going to be our output value. So f of x is going to be a function problems. But there is a specific function that is given, not just a notation, it is limit. The new thing limit when the x approaches to the 1 of x squared minus 1 over x plus 1. So the new question will be limit when the x approaches our 1 value and the x squared minus 1, all of them over x plus 1. So if you want to think about the limit of the x when it goes to 1, before we think about it, we always need to think about the inside the brackets one, which is x squared minus 1 over x plus 1. And if you think about what is x squared minus 1, all of them over x plus 1, as we can see in the easiest way, the x squared term divided by the first degree term will going to give us the first degree term function. So the function in this case, what the function will going to be look like, the function in this case, which we'll notate in our f of x, is equal to a linear function. And what does the linear function mean? The linear function means there is a first power term in our x degree terms, and the reason is because the x squared terms divided by our x terms will going to give us x to the first power term. So this question is about function term because we knew that there is a specific input for that function, and the f of x, which is our function, is going to be a linear function. So this is what the linear function is going to be look like, and we're dealing with our function problem. And in order to think about or solve for this question, we need to think about the linear function itself first. And what is our linear function? If we have a notation in our coordinate plane where it's formed by the horizontal and the vertical axis. So this is what the coordinate plane is going to be, and for the coordinate plane, its definition is a plane where it is formed by our x-axis, which is a horizontal axis, and our y-axis, which is a vertical axis. And in this coordinate plane, the only reason why we use our coordinate plane is to solve for the dots, or we can say coordinate, on our coordinate plane. And the definition of our function is going to be we can say the Venn diagram of our collection in our dots. So for our y value, it will going to be a linear function, and the most basic format of our linear function is going to be a straight line that passes through the coordinate plane. So let's say it looks something like this. This is obviously going to be one of the example of our main linear function, and the definition of our linear function is going to be when the point passes through the x-axis and the y-axis, and it should satisfy its own equation or function that it contains. And when it convert our equation into a format of our graph into our coordinate plane on our x and the y-axis, it will going to be a straight line that satisfies its own equation. So this is what the linear function is going to be look like. So this is a linear function. So this question is basically about the linear function, but one more thing that we don't know about it is our limits. So in order to solve for this question, we have three things that we need to know in order to approach this question. And the first thing is the main important thing, which is the definition as well as some cases of our limits in the function. And the most important thing here is going to be limit. The first thing that we're going to talk about is the definition and some cases of our limits in our function. And for the definition of our limits in our function is going to be a limit. So the limit is a specific value. The limit value is a specific value that a function or the sequence approaches as the input approaches undefined values. So if you think about its definition, the limit value is a thing where the function or sequence approaches, which is going to be f of x. The y value as the input. What is the input value? It is going to be x value when it approaches our undefined values. And what is the case when it is undefined? Well, in the case of the undefined shows that the answer is going to be 0, where it should be always undefined in our function, in our every single types of functions. And the most important thing here is the function or sequence. And from the word function or sequence, we can think about the types of a limits. So the limits can be either in the function or the sequence. So let's think about the second thing that we're going to talk about is the cases. So the cases of our limits. So as we can see, there are two types of cases in our limits. There are the function and the sequence. So, and there will be different formats of our cases in our limits because they are the different types. So for the f of x, where it shows that the limits goes through our function types. So if I rewrite it again for the limits, when you apply it to function, whatever the function is going to be, it can be either linear, quadratic, rational, irrational functions. And if you apply our limits to our function systems, now unlike the sequence one, the limits to the function is going to be look something like this, where it should always include the word limits. So the first thing is going to be when the when the limit of our x value approaches our c value, the f of our x value is going to be what the limits, the formula for our limits is going to be. So it will going to be a formula for our limits when you apply to our function systems. And if you read it carefully, this limits when we apply it to our function system, it is what the formula is going to be. So this one and this one is closely related because they are the types of our function systems, especially when you apply our limits to our function. So if you applied the limit of our x value, when the x value approaches our c value, so when our x value, which is our input, approaches our c value, the limit of our f of x is what we need to solve. So, and then what is the limit is going to be? The limit is going to be what the undefined value is going to be, which means when the x value approaches to the c value, which is the limited value, which means it is the undefined. And undefined function means they are going to be 0 and no answers will come out. So what is the f of x? The f of x is another way to express our y value. That means when the x value approaches our c value, we're trying to solve for the limit, the undefined values of our y value, which is our output values. This is when our f of x, when we apply to function of our limit, is going to be. Now let's think about the second case. The second case is when you apply our limits to our sequence. And before we think about the limits to when you apply to our sequence, we need to think about what is the definition of our sequence. The definition of our sequence is going to be this set of numbers in a particular or the specific letters or in the specific patterns, less when it increases or decreases or increasing in the same patterns with the same equation. So what is the formula when you apply our limits to our set of our numbers, which we're gonna call it as the sequence values? The sequence values, when you apply to our sequence, is going to look something like this. When the limit where our n value approaches our infinite value, the value of our a of n. And this is when we apply our limits to our formula. This is a formula of our limit when applied to our sequence. And if you think about the main difference between them, and before you think about it, let's think about what each variable does inside it. The limits value is exactly same with our function values, but the difference between them is that when the sequence values main form or the standard form is when the value that we're trying to solve approaches our infinite or negative value, and we're trying to solve for the a over n, which shows that it is a sequence value. And we might learn about this more when you apply our sequence values to our function. So this is the difference between the function and the sequence, and the main difference between them is that for the function, the x value always exists, which means the input value always should exist. But for the limits of our sequence, it is not an x value, it is going to be a one of the number in our sets. So this is what it looks like, the difference between the limits of our functions and the limits to our sequences. So if we simplify what it looks like, there are two types of our limits. What are two types? There can be either the function and the sequence. And obviously the formula has the difference, and the main difference it will differ by the input value, which is the x value, and the n value depends on times in our limits. And this is same kind of concept with our trigonometric function problems. This is the same concept with our trigonometric functions, trigonometry, because there are two types in our trigonometry. We're either applying our trigonometric value to our triangle, especially our right triangle, or to our graph. And depends on whether we apply to our triangle and the graph, the values and the names will change. When you apply our trigonometric value to our triangle, it will be a triangle trigonometry. And if you apply our trigonometry to our graph, it will be a trigonometric function. Because the function's most important thing is going to be a graph. So this is what it looks like when you apply the trigonometry. This is the same kind of concept where they have their own format or the cases in our limits in our function. So this was what the definition and the cases of our limits in the function is. There are two types of cases. The first one will be when you apply our limits to our function, and the second thing will be when you apply our limits to our sequence. And the next thing that we'll be talking about is the definition and the format of the rational function. And the reason why we think about it is the rational function is a thing that makes over the limits even further, which means we are applying the limits in more detailed way. So the third thing we're going to talk about is the definition of our rational function. And people might think that, why do we need to solve for a rational function? Because this question is basically about the linear function. The reason is because rational function is any types of function. It includes any types of functions. So what is the definition of our rational function? The definition of a rational function, which is important, very crucial in our limits section, is going to be any types of functions formed by a fraction, but especially when the numerator and the denominators are formed by our polynomials. What are the polynomials? They are the thing that has more than one nomials, which means they can be either binomials or trinomials like that. And the reason why we are doing this is because we always only we almost every day, every single day, when you apply our limits, we mostly apply to our rational function. And we might talk about this in a later videos why we apply to our rational function. But the rational function is the most crucial thing in our limits. And so this is all we need to do. All we need to know when it comes to thinking about the rational function, only its definition. And the reason why we think about the rational function, is because we know that our equation is when the limit. So we're trying to solve the limit when our x value, which is our input, approaches our 1 value, and the x squared minus 1 over in the denominator x plus 1, and this is what we're trying to solve. But if you think about our actual function, our f of x, which is our x squared minus 1, all of them over x plus 1, what is it? It is formed by a fraction, and the denominator and numerator is formed by a polynomials. They're formed by a polynomials. So when it is a fraction and when they're formed by polynomials, what do we call that kind of functions? We call that kind of functions as the rational function. That's what we need to learn, even though it is not important when it comes to solving this question, but we need to know what the rational function is in order to apply or approach our question. So this stuff was basically about what the rational function was, and we applied to our original f of x function, which was basically about the rational function eventually. And now the last thing that we need to do is thinking about, the last step in order to approach or solve for this question is going to be the how to solve for the limits of the rational function. Because we know the definition of our limits, we know the types of our limits, we know what the rational function is. So what we need to do is solve for our rational function's limits. So all you have to do is, let's write our question down again. When the limit, we're trying to solve for the limit, so let's write a little bit higher because we're running out of spaces. When the limit of our x, which is our input, approaches our 1 value of our f of x, which is our function, is going to be x squared minus 1, all of that over x plus 1. This is what we're trying to solve, and this we can clearly see that it is a rational function. So what does this mean is, so let's write it again in the top right over here. So the limit of the x when it approaches to our 1, f of x, which is x squared minus 1, all of them over x plus 1. All we need to do is solve for what does this mean? What does this mean? Actual meaning in our rational function. So that means as the x gets approached, what is the definition of approach? It is getting closer but never intersects. So when the x value is approaching our 1 value, our f of x is going to be undefined. It is getting close to undefined when the x value approaches our 1. This is what it means by that. So that means we are trying to solve for the undefined values to make it defined. And how do we do it? Well, we know that our original function, our f of x, is x squared minus 1. All of them divided by x plus 1. And when you apply our x value as the 1, it will turn into 1 squared minus 1 times x, which is turned into minus 1 plus 1. So it should be 1 plus 1, not minus 1. 1 plus 1. And what is it going to be? 1 squared is 1 minus 1 is 0. This one will turn into 0, which means it will be undefined. So what we need to do is we need to kind of we need to manipulate our numerator into something to make this function defined. So what should we do? The only thing that we can do is reduce our form, or reconcile our function to the simplest form. Then we'll be able to solve for our values when the x approaches our 1. So what was our function again? X squared minus 1, all of them over x plus 1. So what should we do if you want to I guess manipulate this? All you have to do is divide them. And what should we do in order to do it? Well, we need to make x squared minus 1 into a binomial form. And what is the binomial form? It is a form that is formed by two nomials, which we call as binomials forms. And why do we need to use it? We need to use it to factor the quadratic form. But as we can see, x squared minus 1, it has the square term, which means this is a binomial form of our quadratic function. So, as we have talked about this in a lot of videos, so many videos, x squared minus 1, what we need to do, what is our x squared minus 1 into a binomial? When you convert x squared minus 1 into a binomial, it will be x minus 1 times x plus 1. And if you multiply x minus 1 times x plus 1 back, we'll be able to get x squared minus 1. So what is our binomial form? Our binomial form is x minus 1 times x plus 1. X minus 1 times x plus 1. What is this? It is our binomial form. Why did we do it? We did it to reduce our format of our rational function into a simplest form to solve for a value which is the undefined. So it will be x minus 1 times x plus 1 instead of x squared minus 1. All of them over our denominator, which is x plus 1. And what can we do? Well, we know that our values of x plus 1 will be reduced, and we'll get x minus 1. So our answer for this question is when x value approaches our 0, our value is undefined. And this will be our answer, and the reason why we just did it, the question that without the answers, because to kind of realize what the rational functions, we need to kind of realize what the rational functions limits is going to be. And then what is the most important in our function? It will be a graph. So let's graph it. Let's graph this actual function. And in the next video, we'll be able to solve for the more advanced SAT Math Level 2 limit questions, which will be our 2-1. So this is our coordinate plane that is formed by horizontal and the vertical axis, which means it is formed by x and the y value. Well, this is a little bit weird, so let's make it clear. So I will not just do it. This will be our x-axis, and this will be our f of x, which we can also call as the y value. And especially what it is, f of x is equal to x squared minus 1 times x plus 1. And we know that this question is going to be a linear function. And in order to graph it, what do we need? What is the most easy way to graph our linear function? All you have to do is solve for 2 points on our coordinate plane and graph it. So the most easy one is what will happen when the x value is equal to 0 and our y value is equal to 0. So what will happen when we input our x value as 0? It will be 0 minus 1 times 0 plus 1, which is our negative 1. So we will pass through 0, negative 1. Our linear function will pass through 0, negative 1. And for the x value, our y value passes through to 0. So when you apply our when you input our values of our y value as 0, our calculator will say that the x value will be 1. So we also pass through 1, 0. So we can simply think about it this way. So this is our 1, 0. Let's assume that this is 1, 0, and this is our negative 1, 0. So when we make a straight line that passes through its points, it will give us what we call a linear function is. So let's make this point a little bit downward. And this, we need to remember that this function should also pass through this point, these 2 points. So the first point that it passed is 1, 0, and another point is going to be negative 1, 0. But this won't be a right one, because the reason why they say that limit when the x value approaches 1 over f of x, that means that shows that one of our value in this function is undefined. And how do we represent the undefined values? We represent it by the whole. And that means when the x approaches 1, our f of x, which means this value right over here won't be a defined one. This will be undefined value. This is the graph of our undefined limits of our rational function will be. And in the next video, we'll be talking about the new things already advanced the SAT level Math 2, the limits functions, which especially for irrational function, and we might think about it through 2-1 video.